Welcome to Chapter 3, Pair of Linear Equations in Two Variables. Let us start with a real-life situation. Akila went to a fair. She enjoyed rides on the giant wheel and also played hoopla. The number of times she played hoopla was half the number of rides she took. Each giant wheel ride costs 3 rupees and each hoopla game costs 4 rupees. She spent a total of 20 rupees. Let X be the number of giant wheel rides and Y be the number of hoopla games. Condition 1, hoopla equals half the rides, Y equals X over 2, or X equals 2Y. Condition 2, total money equals 20, 3X plus 4Y equals 20. We now have two equations in two variables, a pair of linear equations. A linear equation in two variables is of the form X plus by plus C equals 0, where A, B, C are real numbers and A and B are not both 0. The graph of such an equation is always a straight line. A pair of linear equations is called a system of two simultaneous linear equations. In this chapter we will learn three methods: the graphical method, the substitution method, and the elimination method, to solve such pairs. The graphical method of solving a pair of linear equations. Every linear equation in two variables represents a straight line. When we draw two such lines on the same axis, three situations are possible. Case 1. The two lines intersect at one point. That point of intersection is the unique solution. The system is consistent. Case 2. The two lines are coincident, they are the same line. Every point on the line is a solution, infinitely many solutions. The system is consistent and dependent. Case 3. The two lines are parallel, they never meet. There is no solution. The system is inconsistent. To use the graphical method, plot at least 2 points for each equation to draw its line. Find the point where the two lines meet, that is the solution. For example, x plus 3y equals 6 and 2x minus 3y equals 12. The lines intersect at the point x equals 6, y equals 0. We can verify by substituting back, 6 plus 0 equals 6, and 12 minus 0 equals 12. Correct. The graphical method gives a visual picture of the solution but may not give exact answers when the intersection point is not at integers. The substitution method, an algebraic technique to solve a pair of linear equations. The method has 3 clear steps. Step 1. Express one variable in terms of the other from either equation. Choose the equation and variable that makes the algebra simplest. Step 2. Substitute this expression into the other equation. This gives you a single equation in one variable, solve it. Step 3. Substitute the value you found back into the expression from step 1 to find the second variable. For example, to solve x plus y equals 14 and x minus y equals 4, from the first equation, x equals 14 minus y substituting, 14 minus y equals 4, giving 2y equals 10, so y equals 5. Then x equals 14 minus 5 equals 9. The solution is x equals 9 and y equals 5. If at step 2 the variable also disappears and you get a true statement like 0 equals 0, there are infinitely many solutions, the lines are coincident. If you get a false statement like 0 equals 5, there is no solution, parallel lines. The elimination method, another powerful algebraic approach. The idea is to eliminate one variable by adding or subtracting the two equations. The method has 4 steps. Step 1. Multiply one or both equations by suitable constants so that the coefficients of any chosen variable become equal in both equations. Step 2. Add the equations if the equal coefficients have opposite signs, or subtract if they have the same sign. This eliminates the chosen variable, leaving one equation in one variable. Step 3. Solve the resulting equation to find the remaining variable. Step 4. Substitute back into either original equation to find the other variable. For example, to solve 2x plus 3y equals 11 and 2x minus 4y equals negative 24, the coefficients of x are already equal, subtract the second from the first. This gives 7y equals 35, so y equals 5. Then 2x equals 11 minus 15 equals -4, so x equals -2. The elimination method is especially efficient when coefficients are easy to match. Example 1. Check graphically whether x plus 3y equals 6 and 2x minus 3y equals 12 is a consistent pair. If so, solve graphically. For the first equation, x plus 3y equals 6, when x equals 0, y equals 2. When y equals 0, x equals 6. Plot the points 0, 2 and 6, 0, and draw the line. For the second equation, 2x minus 3y equals 12, when x equals 0, y equals -4. When y equals 0, x equals 6. Plot the points 0, -4 and 6, 0, and draw the line. Both lines pass through the point 6, 0. The lines intersect at x equals 6, y equals 0. Therefore the pair is consistent and the solution is x equals 6, y equals 0. Verification: 6 plus 0 equals 6. And 12 minus 0 equals 12. Both equations satisfied. Example 2. Determine whether 5x minus 8y plus 1 equals 0 and 3x minus 24 over 5 times y plus 3 over 5 equals 0 has no solution, a unique solution, or infinitely many solutions. Step 1. Simplify the second equation by multiplying through by 5 over 3. We get 5x minus 8y plus 1 equals 0. This is identical to the first equation. Step 2. Compare the ratios a1 over a2, b1 over b2, and c1 over c2. We have 5 over 5 equals 1, -8 over -8 equals 1, and 1 over 1 equals 1. All three ratios are equal. Step 3. Since a1 over a2 equals b1 over b2 equals c1 over c2, the two equations represent the same line. Therefore, the pair has infinitely many solutions, the lines are coincident. This is a consistent and dependent system. Example 3. Champa bought pants and skirts. Number of skirts equals 2 times the number of pants minus 2. Also, number of skirts equals 4 times the number of pants minus 4. Find how many pants and skirts she bought. Let x be the number of pants and y be the number of skirts. Equation 1. Y equals 2x minus 2. Equation 2. Y equals 4x minus 4. Using the substitution method, set the two expressions for y equal. 2x minus 2 equals 4x minus 4. So 2 equals 2x, giving x equals 1. Then y equals 2 times 1 minus 2 equals 0. Champa bought 1 pair of pants and 0 skirts. Verification: 2 times 1 minus 2 equals 0, and 4 times 1 minus 4 equals 0. Both check out. Example 4. Solve 7x minus 15 y equals 2 and x plus 2y equals 3 using the substitution method. Step 1. Express x from the simpler second equation. X equals 3 minus 2y. Step 2. Substitute into the first equation. 7 times 3 minus 2y, minus 15y equals 2. 21 minus 14y minus 15y equals 2. 21 minus 29y equals 2. So 29y equals 19, giving y equals 19 over 29. Step 3. Substitute back. X equals 3 minus 2 times 19 over 29 equals 3 minus 38 over 29 equals 87 over 29 minus 38 over 29 equals 49 over 29. The solution is x equals 49 over 29 and y equals 19 over 29. Verification: substitute into both equations to confirm they hold.